Today we're going to start with something called the fundamental theorem of algebra, which sounds pretty important. The fundamental theorem of algebra says that if a polynomial of degree n has n roots. Okay, so if it's degree 5, there are 5 roots. If it's degree 3, there's 3 roots. Now, they may not all be different roots, so we call those repeated roots, and they may sometimes be complex, so they might be imaginary roots, but it will have that number. So that's kind of a way we can use to check. So what we're going to start with is this problem, x squared plus 6x plus 9. We're going to solve it by factoring. We're going to say the number of roots and the types of roots. So x squared plus 6x plus 9, that is degree 2. So we know for sure there are going to be 2 roots. We got to find them. Okay, so we're going to do this by factoring. So we're going to do x, they're both plus. We're looking for things that multiply to 9 and add up to 6, so 3 and 3. And so if we set that equal to 0, x plus 3 equals 0, we get x equals negative 3. And the other one's going to be exactly the same. Okay, so x equals negative 3 is our only root. There is one real root. But it's repeated. So this is a repeated root. We call it a multiplicity. So it has a multiplicity of 2. Okay, because it's repeated. It happened twice. Okay. And then we want to check this on Desmos. I already graphed this on Desmos. Here it is. Okay, so we have our root at negative 3. It's a repeated root, so you only see it once, but there it is. All right, let's check out this next one. It's degree 3, so it is supposed to have 3 roots. We need to find out what they are. So I'm going to start by factoring out a GCF, which is x. That leaves us with x squared plus 25. Now, x squared plus 25, that cannot be factored any further. That's a sum, not a difference of squares. So now what I'm going to do is just set both of these equal to 0 and finish solving. So obviously x equals 0 is done. Subtract 25. And then we'll take the square root. Remember, if you introduce a square root, we need plus or minus. Square root of 25 is 5, and the square root of negative 1 is I. So we have plus or minus 5i. So in this problem, we said we had 3 roots. We have one of them is real, 0 is a real number, and 2 are imaginary. Okay, so there were 3, just like we said there would be, only 1 real and 2 imaginary. And if we look at this graph on Desmos, there it is. Okay, there's our real root, so that is the only place that it crosses the x-axis. Imaginary ones do not show up on the graph. Okay, so just to reiterate, for the fundamental theorem of algebra, it says whatever the degree is, that's how many roots there are. Some might be repeated and some might be imaginary or complex.